Now I will talk about equilibrium or balance. If we have equilibrium now, we have a string and a basket. There's a person inside this basket, and the mass of that person is the mass of the basket is equal to 50 kilograms. The mass of the person is equal to 70 kilograms. How much the total weight? It will be equal to M1G plus M2G. This is both masses together. The weight will be equal to, I can't tell. It is equal to 1,776.8. Just multiply by G, multiply by G. It's simple. Right? Why? Why? This system doesn't fall. I'm asking. It is not falling down. Because there is what? There is a string. It lifts this system. So there is a force in that string. If the string is like this, and we have the weight there, is this logical? It is not tied, but here it is tied. Because of that, there is a force. To this direction, we can name it tension force. Okay. It is the same as, you can imagine that, it is the same as the normal force, but it is not the normal force, it is the tension force. Who can tell me how much the tension force? Assume that our tension force is equal to, not to this, it is 1200 newtons. What will happen? The action after that, we have a weight, this, which is 1100 or something, downward, and 1200 upward. So the force upward is more than the downward. Then the shape of our system will be like this, but it is not. And the basket will start flying. That's not in our system, nature force. What if the tension force is just 1,000 and the mass downward is bigger? The weight downward is bigger. What is the action now? Who can tell me? What? Downward, yes. What will happen? The string will be broken, right? Then the system will fall down. And that is not true in our system. Because of that, we can say that the tension force is equal to that force. How can we find that? It's a simple. We can assume our XY plane like this. This is X, this is Y. Okay, this is X and Y. We have downward forces, which is M1G plus M2G. We have a tension force upward. We don't have any horizontal forces. We have something now, as we see, named balance or equilibrium. Equilibrium has a conditions. In our study now, we don't have any rotation or motion, we just have a linear motion. The equilibrium condition is the total forces should be equal to 0. So the total forces in X direction should be equal to 0, and the total forces in Y direction should be equal to 0. Yes, in X direction we don't have any forces. In Y direction we have the tension upward. We have the tension upward because the positive sign plus the negative m1 plus or g minus m2 g should be equal to 0. This is the y direction. Okay, I have two minuses. I can move them there. They will be positive. Then the tension force will be equal to them. So the tension force here, I will write it. You can know it's there. It is M1 plus M2 multiplied all by G, because I can take G outside as a common factor, which is the total weight. This is the balance or the equilibrium condition. It is satisfied now. If I told you our system is at equilibrium or balance, then direct go and put this condition and put the x and the y forces are zeros. Then start solving. If the velocity is 0, if v equal to 0 or v equal to constant as vector, then the acceleration is equal to 0. In general, if the velocity is equal to constant, then the acceleration is 0. 0 is a number, it is a constant. So in general, if the velocity is 0, is constant, then the acceleration is 0. Then we have balance or equilibrium. Okay, and we can apply Newton's first law because we don't have any acceleration.